So this video is going to be an extension of the previous video for ARC19, and we're going to be minting an ARC19. I would recommend that you watch at least the beginning of the last video so you could figure out how to get this information, the API key, API secret, JWT, algo token, server, and private key from an account that we generate, and also to pip install some of these things here, so python.env, Pinata, and the Algorand SDK. And then we're going to import most of these things to get started. And we're also going to install some new things. So the first thing that's going to be new is from the Pillow library, PIL, all capital, import image, capital I. And you can get this by using pip install pillow with a capital P in your terminal here. So you would just type it out, pip install pillow, and hit enter. We're also going to install from CID import make underscore CID. And for this, you would pip install pi-cid. We're also going to need multi-hash. So we're going to import multi-hash. And for this, you would use pip install pi-multi-hash. I believe if you install one of these, they install both, but just to be safe, just pip install pi-cid and pip install pi-multi-hash. We're also going to need hashlib. You get this by default if you have Python 3 and above. And then we're also going to need from algosdk.encoding, import decode, or excuse me, import encode address. And this comes with the Algorand SDK. Same thing for this here, algosdk.transaction, comes with the Algorand SDK. And then I think we should be good here. Yeah, that's going to be pretty much it. So the beginning of the code will be almost exactly the same as our previous code. So I'm just going to copy from here where we get the asset index until this load.env from the previous video. And all this code will be on the website, AlgoLearn.com, if you don't want to type all this out manually. And I'm just going to zoom out a bit here. And the first thing that we're going to need to change is how we format our metadata. So for the metadata, the first thing we need to change is the standard. So it's not ARC19, it's ARC19. The image, the MIME type, we're going to change to image underscore MIME type. And we can keep this the same as image/PNG. And then the image, instead of defining it in the URL here, which is the link to the hash on IPFS, we're going to actually put it in the metadata so that the image can be mutable and we can change it in the future. So what we're going to type here is just image, and then we're going to input this variable here, viewable hash, which is the Pinata link plus the image IPFS hash. And we're also going to add something called image integrity, image underscore integrity. And this just helps platforms confirm the image that they're retrieving from IPFS matches the actual image you want it to be displayed. And it's kind of a proof of authenticity. So if the image has been altered and they hash the image and it doesn't match the hash for the image IPFS hash, then they know that this is incorrect. So image integrity, this one's going to be a bit of a long one. So it's SHA-256 dash in as a string plus the string of hashlib, the SHA-256 hash of the image, which I'm going to show you how to construct now, 2 bytes, dot hexadigest. And this provides the hex string of the hash of the image as bytes in a string format. And we're going to add a comma here at the end. And to get the image in a format where we can convert it to bytes, we're going to use what we imported up here, the image class from the Pillow library. So over here, we're going to type image, img, is equal to image open, and then the directory to our Charmander. Or we can use this variable here, image path, and just pass that in directly. And then that's pretty much it for adjusting the metadata. Everything else can stay the same. And for the next step, before we define params and actually define our asset configuration transaction as well, we're going to pin this metadata here to IPFS or Pinata, whichever storage solution you are using. So the metadata with the IPFS link for the image is going to IPFS as well. So what we're going to do here is define a file name, and we're going to call it metadata.json. And we're going to use with open this file name, which does not exist in our current directory, but it's going to auto-create it when we open it or write to it. With open file name in write mode as f, json.dump metadata f. So now what this is going to do, and I could run this code now to show you and just comment everything else out. After it uploads the image and defines the metadata, it's going to create a file name called metadata.json, open it, which doesn't exist, so it will create it in write mode and dump this metadata.json. And you can see here that it created a metadata.json. And you can right-click and format to see it better. So the next step, and we can delete this. So the next step will be uploading this file that we create onto IPFS in a JSON format. And we can define here a variable called JSON pin hash is equal to Pinata client that we define up here with our API keys. The Pinata client dots pin file is going to be our file name. So this is going to overwrite our previous file name that we defined for the image. And this next part is a little bit complicated. I don't fully understand everything that works under the hood with this. I don't expect you to either. But I will try to explain it as best I can, or at least just define what I'm doing. So what we need to do is get a multi-hash object decoded from the CID that is interpreted from the hash we receive back, this JSON pin hash. And once we have that multi-hash object, we're going to obtain the digest of that object, which is the bytes format of it. That sounds super complicated because it is super complicated. Basically, it's just a way for platforms to associate this image integrity and the metadata with the standard that you used for hashing. And that's the best I can do for an explanation. You're going to see the code here as I write it. So digest is equal to a multi-hash object decode from the make CID results of our JSON pin hash, access the multi-hash attribute of this result, and then we're going to get the digest from this. And I'm going to print this digest. You'll see it's a 32-byte string. And let me just comment out this here so we don't submit a transaction yet. And you'll see here 32-byte string. Now a 32-byte string, as we know from previous videos, if you're following along the tutorial, is something that you can use to encode into an Algorand address. So an Algorand address is 32 bytes. So in theory, if we type in here ARC19 Algorand address is equal to encode address, which we receive from the algosdk.encoding library, and pass in this digest, we should receive an Algorand address. And we do. So this metadata was hashed, and the multi-hash object its digest, which is 32 bytes, can be interpreted or translated into an Algorand address. And this is how ARC19 works. So this Algorand address that we obtain, and now we can get into defining our params and the actual asset configuration transaction. We use this ARC19 Algorand address that we generated as the reserve address for the asset we're creating. And then we don't need the note field anymore to store metadata. And for the URL, we're going to replace this as well to define the standard for our ARC19 Algorand address and the digest that we obtained. So we're going to write here in double quotes, template dash IPFS colon // curly bracket IPFS CID colon 0 colon DAG dash PB, which is the default encoder for CID version 0, DAG dash PB colon reserve colon SHA-2 dash 256, close curly bracket, and then close the quotation. And we didn't need this quotation over here. And now platforms that see this URL, they will say, hey, this is a template IPFS. That means based on this template, it indicates here that the reserve address is where this template is located and how to decode it. And it goes to the reserve, sees the address, decodes it, and kind of reverses this process to get the link to the JSON pin hash and retrieve information that we uploaded, which is this metadata. And that is the ARC19 configuration transaction. So we sign, submit this, and we'll get a asset index at the end. And then we can go to para with this asset ID. We'll go to, so this is our Charmander, the ARC69 standard. And when we input our new ID, you'll see it says ARC19. I'm not sure why ARC3 always pops up with ARC19, but you'll see here that we still have our properties and the image still generates, even though the asset URL does not point to the image. The image URL is inside the metadata now. And now if we go back, we're going to simulate changing information like we did with the ARC69. So we submitted this transaction, we got an asset ID, and then we created new metadata with the level incremented and experience incremented, and we updated the ARC69 properties information. So we're going to do the same thing here. And to get started with this, we're basically going to repeat the process we did up here. So we can basically copy pretty much everything here up to image path. And I'll add a spacer so we know where we left off. And now let's say you wanted to change the image. So we can do that. Let's say you had a falling out with your artist, or Pokemon company reached out to you and said, hey, you can't use our image, you better change it or we'll sue you. I have here somewhere on my desktop Pokemon images. I have a brand new Charmander 2.0, which we're going to use. It's beautiful. And it's going to replace the existing image that we have here. So down here, when we define the image path, we're going to change it to Charmander 2.0. Everything stays the same here. And we're going to increment the level, so let's say level 4, and experience 15. And for the file name, we're going to do the same thing. We can delete our, or actually it doesn't matter. We can leave that as is. It will just overwrite the previous metadata. And then for the asset configuration transaction, this time we're going to have an asset index. Oh, it's going to be just index equals. And we're going to go up here, find our asset variable, our asset index variable, and pass that in here for the index. And over here, everything else can stay the same, except we don't need a total because that's immutable, same as decimals. We cannot change that. Asset name and unit name, we also cannot change. So this is good. And then we're going to sign this new asset configuration transaction. We won't need the index because we already have that, and we don't even need to wait for confirmation here. So let's try running this. And let me just double check. Yeah, we should be good. So it's going to complete the initial process, and then it's going to repeat that process. It's going to submit the new image. It's going to submit the new metadata to IPFS, and then we're going to use this new information when we configure the asset over here with a new reserve address. So this reserve address will be different, and we can print these here, but we can see that they're different over here. And we'll say here, we'll make an F string, original ARC19 address. And then we'll print the new one here. We'll change this to new ARC19 address. And we'll run this. And as soon as I see this ARC19 asset index, so here's the original address, I'm going to try to catch it and paste it in here. Okay, so this is the original. And if I refresh, this second transaction should have processed already. And you'll see the ARC19 addresses are different. And I'll refresh, and you'll see the new image here. Beautiful. And you'll also see the new metadata properties here. So it's level 4 now, experience 15, opposed to level 1, experience 0. And that is ARC19. So the only catch is, I really wish there was an ARC standard for us to adjust the name and the unit name, but currently there are no ARC standards that support this. So in the next video, our contract, I'm actually going to add an additional method where we can kind of evolve this Pokemon. And basically what happens is they submit this Pokemon to the contract burns it or locks it up, and they dispense a evolved version, which for Charmander, the next evolution would be Chameleon. And that's pretty much it. So ARC69, ARC19, we're going to use ARC69 for the next video.